So most stormwater facilities, and I'm going to talk about stormwater ponds, okay? You could also have underground detention, which are man-made assets, but let's talk about ponds because the ponds today operate like our bathtub, right? Your bathtub has this outflow hole at the top. If the water gets too high, it hits the outflow, and that way you don't flood your bathroom. The way stormwater ponds work, and you see them next to highways and large parking lots, any kind of paved over impervious surfaces. And the idea is to get the water to flow into the pond. And while the water sits in the pond, dirt molecules and pollutants connect. Gravity takes them to the bottom of the pond, and Mother Nature does her thing, munching it up. What we do is we add technology to this setup. So back to the outflow hole, we put an automated valve on that outflow hole. Okay? We could sink a pipe to the bottom, which gives us access to the full capacity of the pond. And we also are monitoring the weather forecast to understand when to turn that valve. So you've got Internet of Things technology out at that site. We typically run on solar power. So we have an actuator that acts as the engine to turn that valve. And then it communicates over to the cellular networks back up to the OptiCloud. It knows the configuration of the pond, how large is it, what are the real-time conditions with the pond. So how much water is in the pond? How long has it been there? Are we measuring for any pollutants? And we're monitoring the weather forecast. Now, the weather forecast will tell us that a storm's approaching, and we can get a 48-hour advance notice. So once we see that a storm's coming, we'll begin to calculate how much water is going to flow into this pond. Is there enough capacity, or do we need to draw it down before the storm? And by drawing it down before the storm, it's like adding another 60% capacity. If we go back to the passive method, nothing would be pulling that water out. When we pull it out before the storm, it's cleaner because it's been resident in the pond. It might be flowing down to wetlands. Also control how fast that water comes out so we don't erode any food source in the wetlands, like streams and whatnot. If it's going to a wastewater treatment plant, it's going to the wastewater treatment plant before the storm so the plant has capacity to process it. Right, the issue, particularly here in the Northeast U.S., we have a problem with combined sewer overflows. And what that means, CSOs, what that means is when there's a storm and these passive methods are working, the wastewater treatment plant gets overwhelmed and it pushes sewerage right out into nature's waterways. So by being able to process the water ahead of time, we create more capacity during the storm and we keep it out of the wastewater treatment plants, thereby reducing combined sewer overflows. So as an example, we have a setup in the city of Albany, New York, the capital of the state of New York. We're reducing about 200 million gallons of CSO a year for them by these methods, which we call CMAC, continuous monitoring and adaptive control.
And what's your process of working with government or city council clients to get them to agree to put these in place?
So, number one, we need to have regulatory approval. Right now, we do have regulatory approvals in some of the, I'll say, most advanced environmental states like Maryland, Washington State, and they get reciprocity. That gets us reciprocity into other states, but we still may have to go through that. So that's a hurdle we need to get through. Then, yes, we'll work with municipalities. We work with sewer authorities. There are some stormwater utilities. It's highly fragmented here in the States. We have over 40,000 water utilities. So you have that. We also do a lot of work in the private sector because in the private sector, we can take that pond and we can shrink it by about 50%.
And some of your case studies where you're working with actual rooftops on buildings as well to try and reduce the amount of space they need to gather rainwater and to then recycle some of that for irrigation on buildings, which is quite a...
Those are some of my favorite stories. We have an apartment developer we work with in New York City. He has a couple of comments to say. One is, with Opti, my buildings don't flood any longer. Without Opti, he still meets the requirements by the city of New York, but his buildings would still flood. So the technology really helps. Now also, we're capturing that water and we're pumping it up to the rooftop, where there's a rooftop farm that handles produce for 4,000 people. So we have a little motto: stormwater is an asset. Right, let's cure it, let's filter it, let's use it for property irrigation rather than tapping into the municipal water supply. done with a beautiful office building here right outside of Boston. Saved them about $2 million in their build out. So they could put in smaller underground detention blocks, which saved them about $800,000. We're capturing the water, we're moving it over to an irrigation system where it's properly filtered. That's saving them about $50,000 a year in operating expenses on the municipal water bill. And they are now set up for more expansion on that parcel, because we have a more advanced offering we call Smart Watershed Network Management, where we can actually network these assets together and control the flow of the total across the watershed, not just the single site.